And finally, we get to the very last part of the lab diary, where we've got a value for g. We just calculated that in the last part, but that's not the end of the experiment. We need to know what the error in that value of g was. So in this example, what we're going to do is use the max-minimum gradients that we've already calculated. And I knew we were going to have to do this while we did it to the point we plotted the graph. But in reality, at this point, you can go, right, what do I do now? And go back to your graph and do that at this point. So the max line of best fit, again, we just put the calculation in, gives us a maximum gradient, and we do the same thing for the minimum one, gives us a minimum gradient. So we've got the max is 4.1-ish, and the minimum's 3.7-ish, so we can see a bit of a difference there. And we just do the same calculation we did before, G max, G min, work out a maximum and a minimum value for our G. So then we can calculate the difference between that and the original, our original of 9.76. So the plus error is 0.8 bigger, and the minus error is only 0.2 smaller. So we can give our very final value as 9.76, which was our value. Instead of giving it a single plus or minus value, we can give a different plus and a different minus value. And we write it like that in this case, just at the top of the screen there. So 9.76 plus 0.8 minus 0.2. So this is something which happens only as a result of doing the graphs manually and working out a different maximum and minimum. When you work on to slightly more advanced stuff and you get some software like Excel to do this for you, you won't actually have that. You'll just end up with an error in the gradient and you'll propagate that. So this is what works for sort of a manual calculation. And some bits of software would work this way as well. So it's a good one to get your hands dirty on and see what you've done. Another little useful thing that we've just done there at the end is calculate what percentage the plus and the minus is. Again, if you'd only got one, you could just do this for one, to give it an idea of the percentage error. As it's so different, I've just taken a mean of those. So it gives me 5.1% error. Now, 5% error is reasonably acceptable. Anything over that starts to get a little big, so we're on the border of it being acceptable. And one of the things that we've been asked to do initially was to compare this value. And even if we weren't, it would make sense to compare the value that you've got to an accepted value. So I've put in a reliable reference. No, actually, technically that's a bit of a mistake, really. I should have cited it there and put that reference a little bit at the end. But again, it's a bit of a rough document. If this was a lab report, I would cite and put that reference at the end. All that really matters for your lab diary is that it is referenced. It doesn't necessarily need to be put in a reference list at the end. That's a very formal version. So we give 9.81. You can't just say, well, I know it's 9.81, it's always been 9.81, because actually it's not. In certain places on the planet, it is not 9.81. You're not even going off into space to find that. But this is the value I've found from a relatively reputable reference site. And it gives the 9.81 as the average, and it's quite happy with that, so I'm quite happy with that. And I can then compare 9.81 and 9.76, and I get a percentage difference. So having a percentage error in my answer gives me an idea of how significant the error is. Just seeing the plus or minus as an absolute error doesn't always tell me. A percentage error gives me an idea of how big it is. If it was 20%, that's really bad. 5% is okay. But this is another technique. Now, I've got an accepted value, and I want the difference between mine and the accepted value as a percentage. Again, it lets me see how significant it is. And in this case, it's only about 0.5% away from the actual value. So that's a reasonable degree of accuracy. And I don't just calculate it, I should put some comment in. I know it's only the lab diary, but we still do things for a reason, and we want a bit of a comment in there. All of this information really is where you finish. We don't get into any heavy discussions or big problems unless you've got anything you want to make a note of at this point. If you were going on to use this lab diary to make a lab report, all of this would form a good basis for a discussion where you would talk about now all the things I've just been saying about whether the error is big or significant, whether it's accurate compared to the accepted value and things like that. But for the lab diary, this is pretty much now the end of the road. Just double check in the instructions in the original brief that you were given, was there anything else you're supposed to have looked at or done? Any other information you're supposed to have given or final little comparisons? Just make sure you've done everything you've been asked to do. But at this point, that is the lab diary in its entirety. So there's a lot of work there. A lab diary is quite an involved document. But if you do a really good job of it like this, then when you come to write a lab report based on it, that is so much easier. if you've already done most of the legwork.